All right, in today's lesson, we'll be learning how to graph sine and cosine functions now on a graph. So there was a piece of paper that hopefully you had printed out on graphing sine and cosine graphs from the unit circle. So you need two different colors for this, highlighters or two different colored markers. On the forward radiuses on the unit circle, you're going to label the points as 0, pi, pi over 2, pi, 3 pi over 2, and so on. And you're going to put these points on those specific spots with your pencil. And then we're going to talk about how to plot the points. So here's what your paper should look like. So I am going to be now labeling on here those points. So this is the point 1, 0. At pi over 2 is 0, 1. At pi is -1, 0. 3 pi over 2 is 0, -1. Now we have to remember on the unit circle that the x component, which is the horizontal, that is cosine. The y component, which is the vertical component, that's your sine function. So here is a graph, your x and y axis. On the x-axis is labeled all of the radians, and they even actually continue past the 360, the 2 pi, pi over 2, and 3 pi. And then we have our y-axis labeled as 1 all the way down to -1. So what we want to do, let's take a look, and I'm going to do mine in blue first. We're going to do cosine first. I'm going to put blue here, cosine, on my key here. So cosine is my x. So at 0 pi, cosine is your x, which is the 1. I'm going to go to 0 pi, and I'm going to plot 1 right here on the y-axis. Then I'm going to go to pi over 2. The x here is 0, so at pi over 2, I'm going to be right at 0. Then at pi, my x is -1, so I'm going to go down to -1. At 3 pi over 2, my x is 0, so I'm back up to 0. And then if I go make a complete circle, this is actually also 2 pi. My x again is 1, so I'm up here at 1 at the 2 pi. And then I'm going to connect it like this. So a cosine graph always starts at something called the amplitude. Always starts at the amplitude. And it looks like a U shape. That's what it looks like to me. Almost kind of like a parabola. All right, so now let's talk about sine. So I'm deleting these, deleting this. I have to re-sketch this in. So this is 0, 1. This is -1, 0. 0, -1, 1, 0. Okay. All right, now I'm going to do my sine in green. So I'm going to make the key green. So at 0, sine is your y coordinate. So that makes it 0. So it's starting right here. At 90 degrees, pi over 2, the y is 1. So it's going up to 1. At 180 degrees pi, it's at 0. At 270, 3 pi over 2, it's at -1. So it's a different looking graph, right? And then at 2 pi, it goes back to 0. So there is what my sine graph looks like. So my sine graph always starts from the x-axis to 0. And it looks like a backwards S, I guess you could think of it. I could have kept going to 5 pi over 2 and 3 pi, but I'm not going to do that. So this is a basic cosine graph and a basic sine theta graph. All right, now these are important things to put in your notes here. Depending on what's given now, because things are going to happen to sine and cosine graphs, whatever number is in front of the sine or the cosine function, that is your amplitude. That's telling us how high or low the graph is. And we're going to always take the absolute value of it because we want to go up that height and down that height. My period is how long to make one cycle of the graph. So we're going to need this to know, okay, where am I going to start the graph and where is it going to end? And we're going to do 2 pi 360 divided by the b number. And where's the b number? Is inside the parentheses in front of the x or in front of the theta or whatever letter they're using there to represent the angle. Then we might have a phase shift. So we might be shifting it horizontally somewhere along that x-axis. That's if we have a c value. So we would take negative c and divide it by the b. And then I also might have a vertical shift. If I have a vertical shift, that means it's going to be shifting up or down, right? And that's this d value here, this d value, this vertical shift is this d value. If I don't have a d value, my midline is going to be right on the x-axis. All right, so let's take a look at now. There was another piece of paper to print out that has all 5 of these things on one. So you have the graph paper with each equation. I kept this box on the left side so we could reference it. So we're going to graph y equals 2 sine 2x. All right, so let's get our amplitude first. So that's our absolute value of a. Our a is this 2 here in front. So the absolute value of 2 is 2. Let's get our period. How long to make one whole cycle of this sine graph? That's going to do 2 pi divided by b. Now remember, 2 pi is 360 degrees, so I can replace it with 360. Where is the b? That's the one that's in front of that x, so I'm going to divide it by 2. So 360 divided in half is 180. So it's only going to be 180 degrees to make one whole cycle of a graph. Is there a phase shift? None, right? There is no C here. There is none. And is there a vertical shift? No. Okay, so let's make an X and a Y. I'm going to go to the left side because it's not being shifted at all horizontally. And now we need to make our period here. So what I'm suggesting everyone to do is to have at least 5 points on your graph, 5 points. So the first point is going to be at 0. So my starting point is going to be at the phase shift, but there is no phase shift, right? So it's going to start at 0. And my ending point is going to be my period. Phase shift plus the period. Since my phase shift is nothing plus the period, that means I'm just going to go out 180 degrees. How do I get the points in between? It's kind of doing an average. So I'm going to go out, let's say 2, 4, 6, 8. I'm going to go out to about here. It doesn't really matter. What will be the middle of this graph? Well, 90 degrees, because half of 180 is 90. What's half of 90 degrees? 45 degrees. And what's in between 90 and 180 is 135 degrees. I'm going to be going up my amplitude as 2. So I'm going to go every 2 boxes. This is going to be 1. This is going to be 2, so I can see the graph a little bit better. This is -1. This is -2. Okay, now we start plotting the points. This is a sine graph, so a sine graph looks like this S, right? So I'm going to go start at 0, my x-axis, go up to the amplitude at 45 degrees, back to the x-axis, down, and then back over. So this is what my graph should look like. Oh, let's try another one. We're graphing y equals 3 sine 2x minus pi. All right, so what is my amplitude? Absolute value of a. Here's the a again. So the absolute value of 3 is 3. What is my period? 2 pi divided by the b. Where's the b again? In front of the x. So 2 pi divided by 2. All the 2's cancel, so all I'm left with is pi, which is 180 degrees. That's how long to make this graph. Phase shift. All right, we actually do have a phase shift. here's my c. It's negative pi. And the formula says negative c over b. So a negative of a negative becomes a positive. So it's pi over 2, which is 90 degrees. So I have a phase shift where it's starting at 90 degrees. And we have no midline, so it's not shifting up or down. So let's make our X line, our Y. So remember, we need 5 points for the graph. So our starting point is our phase shift. So our starting point here is going to be at 90 degrees. So I'm going to go a little bit out from the 0. I'm going to go right here, 90 degrees. Our ending point is going to be our phase shift plus the period. So that is 90 plus the period, which is 180. So we are going all the way to 270. So I'm going to go count by boxes. Let's say 2, 4, 6, 8, say about here. Now, what is in between 90 and 270? Well, I could take these two, because I need 3 more points, right? 3 more points in the middle. So I want to get what's the average of 270 plus 90, right? Divide that in half, so that's 180. Then what's in between 90 and 180? That's 135. What's in between 180 and 270? That's 200 and, I think that's 215, right? My amplitude is 3. So 1, 2, I go up every 2 boxes, down to negative 3. So 1, 2, 3. And this is a sine graph, so that means I'm starting at the x-axis. 90 degrees is going up, is going to 180, going down. There it is. There is your sine graph for this one. Okay, here's the third one. Why don't you go ahead and find amplitude, period, and phase shift. Stop the video, come back and see if you have those 3 things right. Okay, here are the answers that I got. 3 amplitude, period is 180, and the phase shift is negative 90. All right, so when we graph this one here, it's going to be a little differently because we're going to be on the left-hand side of the y-axis, right, at negative 90. So I'm going to go about, no, let's go 2 boxes away, negative 90. Okay, so we need to plot 5 points. So our starting point, I just did, was our phase shift. Okay, our ending point is our phase shift plus the period. So that is negative 90 plus 180. That ends at positive 90 right here. Okay, so that means the middle, the third point would be right at 0. And what's in between 0 and negative 90? Negative 45 degrees. And what's in between 0 and positive 90? Positive 45 degrees. This is going up to 3. I'm going to go every 2 boxes. 1, 2, 3. And down to negative 3. And it's a cosine graph. So cosine graphs are going to start at my amplitude. So it's going to be up here. And it's going to be going down to the x-axis, all the way down to a lower amplitude at 0 degrees, then up at 45 and back up to 90. So here is my skinny U-shape. I probably should have made the boxes wider, but I didn't there. Okay, here's the 4th one. Stop the video, see if you could get how much you could get through, including the degree forms for the 5 dots, and then come back and watch. Okay, so let's take a look. We do have an amplitude, it's 5. Our period is 360. There is no phase shift. And there is a vertical shift here, so something different, a vertical shift of 3. Did you get these 5 points? It went from 0 to 360. Then we had 90, 180, and 270. All right, now, the vertical shift means it's going to be going up 3. So what I like everyone to do, and I'm just in a different color, actually going to go up 3 boxes, 1, 2, 3, and I'm going to actually make a new pretend x-axis. Now, from this spot where this new red dotted line is, I'm actually going to plot now my 5 points using that as my axis now. So I'm going to be starting at 0, and sine is that, always starts from that x-axis. This is our new pretend x-axis. It's going to go up how much for the amplitude? 5 boxes, so 1, 2, 3, 4, 5. So it's going to be going up all the way over here for 90. Then it's going to go back to the x-axis. Then it's going to be going down 5, 1, 2, 3, 4, 5. And then it's going to be going back up to the x-axis. So this is what my vertical shift looks like. Well, let's just think about it. It went up 3, right? And it still's got the height of the amplitude of 5 on the top and 5 below it. Okay, here's the last one. See if you can get the information first, and then come back and see if you have the right answer. Okay, here are the amplitude, period, phase shift, and vertical shift. It's a little different this time. It's a lot easier, actually. Instead of things in radians for the degrees, they are just in numbers. So it's easy to figure out the middle of each of these. So I started at 0 because of no phase shift, and ended at 8. And then the middle of that is 4. The middle of 0 to 4 is 2. The middle of 4 to 8 is 6. And there's the cosine graph. My bad on the previous graph here for sine, I did something wrong. So, because this has a -5 here, that means it should be reflected. So instead of it going up, I'm going to do this in green, it actually is going to start here, but it's going to go down. So I'm going to go down 5 first. 1, 2, 3, 4. So it should be here, back up to the x-axis, and up 5, then back to the x-axis. So get rid of the one that you had, this black one. Those are not good. And it's the green one. Sorry about that.